Assalamualaikum warahmatullahi wabarakatuh and good day to the panels and audience. Today, I will be presenting about my final year project proposal with the title Design and Techno-Economic Assessment of an Agro Photovoltaic System. First, let me introduce myself. My name is Norfarihah binti Ahmad rasdi and my supervisor name is Prof. Madya Dr. Ramlan bin Zailani. This presentation will be divided into 6 chapters, which is Introduction, Literature Review, Problem Statement, Objective, Methodology, and Expected Result. For introduction, Agro Photovoltaic System is the combined production of photovoltaic power and agriculture crops on the same area. The coexistence of solar panels and crops implies a sharing of light between these two types of production. The main purpose of creating agro-photovoltaic is to meeting a global energy demand to overcome food security and replacing fossil fuel that was threatened by the impact of growing world population. In 1982, the first design was introduced by raising the solar panel 2 meters above crop production and create the spacing between them to avoid excessive shading of crops. Nowadays, many designs and further technology improvements was invented to increase the efficiency of agro-photovoltaic system and suitability for application in the crop production. While rainwater harvesting system is a technology or simple process that used to collect, stores, conveys and purifies rainwater for the later use. The aim of collecting the rainwater is to keep it for reuse instead of letting it just run off. As the world population grows, the demand for a process supply is growing higher too. Sustainable use of water could maintain a balance between the demand and supplies. So, rainwater is the easiest and sustainable method that used to reduce the pressure on process supply water, which can enhance the green living. Rainwater harvesting system consists of a catchment, conveying system, filter and tanks. The process of rainwater harvesting system was one of the best methods that can be followed and practiced to support the conservation of water. So, the combination of agro-photovoltaic and rainwater harvesting system in one design can improve the renewable energy production, reduce water loss and also improve the food production. For the literature review, according to the N.F. Othman from University Putra Malaysia, agro-photovoltaic can promote the reduction of carbon emission for usage of fossil fuels, and the calculation of growth rate can be done based on the Monte Carlo simulation. Second, according to the Takashi Sekiyama from Kyoto University, the performance agro-photovoltaic system can produce electricity and crops simultaneously, with the installation of stick-mounted photovoltaic on the farmland. Lastly, based on the journal from Charlene dos Santos for KTH Industrial Engineering, he studied about the developing a combination of electrical production with the agriculture on the same land and the impact of fixed and dynamic solution on the crop below the solar panels. For the problem statement, the average of sunlight received every year in Malaysia was 2,228 hours. Malaysia also received 2,420 mm annual average rainfall in Peninsular Malaysia, while 2,630 mm in Sabah and 3,830 mm in Sarawak. Unfortunately, these great potential and advantages are not fully explored in the modern agriculture. Therefore, the design of combining PV energy generation and rainwater harvesting system, their benefit could be materialized. The objective of this study is to design a compact agro-photovoltaic which include the photovoltaic energy generation and rainwater harvesting system. Other than that, the objective of this study is to evaluate the technical operation and economic assessment of the proposed design. The scope and limitation of the project is The proposed design of the combination agro-photovoltaic system and rainwater harvesting system is based on Malaysia climates only, which is hot and humid throughout the year. This design may not be suitable for other countries which have 4 seasons. The overall cost to implement the proposed agro-photovoltaic design could be high due to the cost of the solar panel. Hence, the main aim of the design is to maximize the efficiency of the solar panel. For the methodology, the study starts with the problem identification, literature review, idea generation and conceptualization, material selection, and lastly is the preliminary design. The table shows the economic assessment of agro-photovoltaic system in Malaysia. The economic assessment divided into two, which is direct cost and indirect cost. The example of direct cost is a PV modules, racking materials, inverter, installation labor, balance of system, EPC overhead and profit, equipment rental and freight, and contingency. For the example of indirect cost is engineering design, permitting and interconnection, sale tax basis, and development cost. The total install cost per capacity is RM5.72 per watt. The figure shows the preliminary design that was sketched using hand sketch. The figure 1 shows the front view of the design, while the figure 2 shows the top view of the design. In this design, we are combine the agro-photovoltaic system with the rainwater harvesting system. The table shows the main component for the rainwater harvesting system and its function. The function of tank is to store the water. The function of filter is to remove impurities for the water. The function of PVC pipe network is to convey rainwater to the tank. The function of pump is to transport water from one place to another place. Next, the function of automatic top-up valve key is to prevent potential wastage of water due to the tank or duct failure. And lastly, the function of sea level tank level indicator is to determine the level of liquid stored in the vertical tank. The design details for the agri-photovoltaic system is: we use 20 modules of solar PV with the power of 400 and 450 watts per solar modules. The weight of solar modules is 80.7 kg per solar modules. The dimension of solar modules is 1685 mm of length, 1000 of width, and 32 mm of thick. The type of solar modules is crystalline solar modules, and the inclination of PV module is 26 degrees. The design details for the rainwater harvesting system is: in this design, we use 25,000 liter capacity of the tank size. Filter mesh size is 0.65 mm. The type of pipe network is a PVC, and the size of pipe network is 150 mm. The workflow for agri-photovoltaic system is: the system operation starts with the solar panel absorbing the sunlight with the photovoltaic cells and generating electrical current at inverter where it is transformed. The DC current from the photovoltaic is converted by the inverter to a usable alternating current. The electric energy is utilized to operate the pump and the cooling system, and any excess of the energy will be stored by the battery banks. The workflow for rainwater harvesting system is: the system starts with the rainfall capture the top surface of solar modules and then collected to the MS sheet channel. Then, the water will flow to the PVC pipe network to a water storage tank. The water is passed through a robust pre-storage filter that consists of two primary functions, which is filtration and oxygenation. At the filtration, the major contaminants will be filtered out through the filter. After that, the water will go through oxygenation, which is designed highly oxygenate the water to keep the water pure and naturally fresh. The expected result that I wish to achieve through this study is, first, to propose the combination design of the Agro photovoltaic system and the rainwater harvesting system. Second, to estimate the total energy generation of solar PV. Third, to estimate the average rainfall data per month. Fourth, to estimate the capital expenses and operating expenses. And lastly, to estimate the financial evaluation parameter of the design. That's all for me. Thank you for watching.